Hello everybody, and welcome back to the channel. This is Michael, KE4EST, and I thought I'd do this kind of an addendum video, an add-on to the last video about this IM-1202, and kind of go over and show you doing the alignment of it. I've got the book here that goes over the alignment, and just kind of show you what they're, mean and whatever. Let me turn this around here, and if you've got one of these, you can look at it and reference it and go by it. And you can see I have added some wires here. I just tack soldered them in just to kind of help me while I'm doing this video, because it's kind of a three-handed job just about anyway, because you want to take your probe and stick it to the back of the meter, but you got to have the meter the other way, and if you ain't got a mirror or something, kind of look at it to see what's going on. So it'll help a whole lot doing this video. But if you've got one of these, where everything, you can kind of reference as we're going along here. Right here's your DC calibration, where you put your tip at. Over here is your AC calibration test point. Okay, and then right here's for your ohms calibration test point. You got 200, 2K, 20K, 200K, and 2 meg. Now I've just got a couple here. I'm not going to go through the whole thing. Once I do a couple, you'll kind of see that. Your zero adjust is right in here. All this stuff, you can get from the back here. DC calibrations here, AC calibrations here, and then over here you can see your different. Kind of hard to see there, maybe. Let me see if I can. But if you got one of these, you can kind of see it better in person. But your 2 meg, your 200, 200K, 20K, 2K adjustments are here. Okay. So what I'm going to try to do is turn this around so that you can see it. Get rid of this slide here. Let's see what happens. I guess I'll leave it on there, but you can still see it. And I just took and screwed a alligator clip on the end of my meter here. So let's kind of get through this real quick here. I'll make this too awfully long. So it goes over and tells you about using the alignment tool and all that stuff here in the book. With your function switch, it says to off, range switch to 2, 30 switch to plus, and plug it in and all that stuff, which I've already done. Turn the function switch to DC volt position and allow the unit to stabilize for at least 30 minutes. Note the plus polarity lamp and the 2 right hand digits displaying any number and the decimal point to the left of the digit should all be lit. No other lamp should be lit. That's what we got here. And you can see the plus signs lit up, and you got 2 zeros over there. Use the alignment tool and turn the zero adjust control until the readout is 0.01. And slowly turn the control until the readout just starts alternating between 0.01 and 0.00. Nothing should be plugged into the jacks at this time. Now I've already done that part too. And have anything plugged in down here. Went to zero adjust and zeroed it out. And you can see it's holding pretty steady. It's been plugged in here for about 2 hours, probably 2.5 hours. I've been doing other stuff and come back over and say, well, I better shoot this video. This thing's sitting here. So, and it says plug in the red test lead into the red V input jack. And that's this right down here. Okay. I've done that. And then there's a value wrote on the back of that, and then like here, let's see if I can show this. Somebody's wrote it in here. It's probably Charlie. Wrote it in the back here. It comes in when you're putting the kit together. It comes in this little calibration packet with your resistors and stuff. And if you had this as a kit back then, with the number stamped on it in the envelope, and it says write that down in 2 or 3 places so you don't lose it. Something they've already picked at the factory when they put the resistors and everything on the test bench and made some notes. So It says touch the red test lead probe tip. Now this should be on 2, which okay it is. To the DC cal control until the readout matches the value given on the calibration voltage envelope. Blah blah blah. Observe the number on the envelope, 4 digits, and then it shows you here. Let me show you. It's saying, you can see that moving the light again. If it says 1.943, then that's going to be 1.94. You just drop this digit here, that 3. If it's 1.46, then you just, round up, maybe 1.95 is what they're saying there. If the value on the envelope is 2 or higher, the multimeter over the lamp will be lit. The multimeter over lamp will be lit, but the 2 will not be displayed. So if it was 2.112, that would be over and then 0.11, because you drop this 2, so it'd be, the over would be lit up and it'd be the 0.11. Okay, so what we need to do is clip this on, or hold it on there if you don't have it, to the DC. Well, that didn't work out too good, did it? I told you I had that tack soldered on there. Okay, let me just try to hold it on there and see what it shows here. Okay. Yeah. Let's see. Here we go. Well, I'm looking in the monitor now so I can see this. 1.89. And the back of the thing says 1.87. So maybe 1.88. So what you'd want to do is adjust that DC in the back to match that. But before we do that, we've got better things nowadays. If you have a more modern, pretty good, voltmeter, multimeter, or whatever, you can hook it to a known voltage. Or if you have a voltage reference, like I've got, kind of see in the background hooked up here, you can hook it to that. So what I'm going to do is hook it up to that. Okay. You so hooked it up there to that, and we're reading 10.0 volts. So that's why that one's off just a little bit than what the factory said. Because I used one of these, and I used another modern multimeter and hooked them up. It says 10 volts on this. One of the, these little reference voltage things you can buy. Get them pretty cheap off of eBay and Amazon, things like that. They make different ones of them. Some's got a selector on where you can change the voltage. This one's just 10 volts. But you can see there we are 10 volts. So if you got something like that, if not, you go in there and adjust that. Reach back and put it through the hole and adjust that. So I've got it on there, and that's doing pretty good there. And like I said, it's been sitting warming up, so I've noticed this thing's pretty good for its age. As I mentioned in the last video, it's not doing too bad. Okay, now we want to disconnect the probe from the DC test point. Turn the function switch to the K ohms position and adjust the oscillator control for a readout of over 0.85. Okay, so what they're wanting you to do here, oscillator's right here on the side. I failed to mention that earlier, but that's the oscillator control right there. So if we move this over to here, we should have over and the 0.85. And that I've already adjusted at one point. And we can go in there, see if I go in there and test. See, that's wrong. And I'm adjusting that. So about right in there somewhere, because it says it can be plus or minus 0.15. So that's close. If you are unable to obtain a reading of exactly over 0.85, obtain the nearest possible reading with the oscillator adjustment control. And it's also mentions that it's going to change depending on your line voltage and stuff like that. So you may have to adjust it periodically, depending on if you move this around or whatever. If it's, you can not always, before you start, you take this somewhere and go do some test measurements with it. besides, you know, your normal shop or your house or whatever. Flip this to here, and if this is reading way different than 0.85, then you may need to do some adjustments with it. What they're telling you, it's not going to be exactly as accurate, so you need to, you know that. Okay, so turn the function switch to the DC volts position. Okay, we go back up here and repeat the previous steps until the correct readouts are obtained in both switch positions. So what they're saying is go here, go back to the back, adjust for, you know, like this one's 1.88 volts, you know, be on 2, of course. Then go back to here, adjust this, go back to here, adjust to 1.8 volts, go back to here, get this as close to 0.85 as you can until you get that as close as you can, you know, back and forth. In any alignment, you know, you want to do that. You know, I've mentioned in several videos, you know, when you're doing a radio alignment or whatever, you go back and forth, round and around a few times till you get it stabilized as best you can get it. Okay, and that's what they're saying. So now turn the function switch to the DC position. Okay. Now, so set the front panel switches in the following positions. Function switch DC volts. Okay. Polarity switch plus, which we have, and range switch 20. Touch the probe tip to the AC cal TP, which is AC calibration test point, and adjust the AC calibration adjust, ADJ, adjust control, next to the AC TP for a readout of 16.3. So before we go to AC volts, we want to do this. Let's see if this one's going to stay. Okay. And we want 16.3. As you can see, we got 16.7. So that control is right beside that. So I'll reach back here and go in there to it. I can find it. Okay. Adjust that down. Oop, right there. 16.3. Okay. It says note the reading may vary a little bit, but gets close to 16.3. It says a proper adjustment will read out 16.3 most of the time. So try to keep it, get it at 16.3. Remove the probe from the AC cal test point and turn the function switch to the AC volts position. So we'll take that off. Put this to the AC volts position. And it's going to take it a second to settle when you do that. It always does on these things. Just the way the 74 series logic chips are doing their timing and counting in there. Okay, and I think it mentions here somewhere when it settles. Yeah, allow the display to stabilize. And adjust the, well, let me back up a minute. Remove it from the AC cal and turn the function switch. Place the probe back on the AC cal test point. Allow the display to stabilize and adjust AC cal control, which is up here at the top of the unit, for a meter reading of over 00. So we want this to say 00, but over here. So go to that AC and see we've got, let it settle. That's pretty close right there. See how it's kind of jumping. If it's 0.98, 0.99, there it is. See, it's flickering. It's over and 00. That's where you want it. Okay, so that one's pretty close. Okay, the readout may vary between 19.9 and over 0.0 and over 0.1. A proper adjustment will read out over 0.0 most of the time. And then again, repeat the previous 2 steps until the correct readouts are obtained in both positions. So you go back to DC volts, get 16.3, go back here, and when that settles down, you know, you're adjusting back and forth. 16.3, like it says in the book, and earns for the over 0.0. Okay. And I'm going to move this to here. It says move it to this, back to this position here. Okay. And put this on the 200 ohms reading. And when we're, see, here we are with that over and the 0.85, 0.86. Okay, as long as it's around in there somewhere, that's the way it's going to read and work, you know, properly. Get the most accurate reading. Okay, remove this from down here, which I've got it zoomed in a little. Let me move this just a tad there like that. I had it in here. Let's move it from here. Put it in here. Okay. And I tried to put that. You can see it. That display's looking better without the light right on the front of it. And then, see if I can show you this. There's your chart. 200 ohm to 20, 200 and 2K, which is on the face over here, which corresponds to the 200 ohm is 200 ohm. 2 is like 2K, 20 is 20K, 200 is 200K, 2K is 2 meg. So what's on the front here, when you're doing the ohms, this is 200 ohms, but these, like where it says 2, just put a K on it. That's 2K, 20K, 200K, 2K with another K, you know, 3 zeros, add 3 more zeros, that's 2 meg. Okay. And then you just go through and adjust it. So it's 200 ohm here. So we'll clip on to 200 ohms there. And what you want to do, let me get back here and find this 200 ohm. Okay. You want to adjust that. I had it in there and lost it. Because you gotta think we're at 200 ohm scale, so with this thing got a whole lot of extra, you know, digits on it. So this is 197, 198. Oh, so it's really, really touchy. They go 199. Then they go right there, right there. Yeah, almost. Let's say over, and then 0.00 would be 200 ohms. Okay. So what you want to do, it says do it all of them. Your meter reading on all these here is going to be over 00, over 0.00, over 0.0. It'll tell you, but that's what you're looking for. So like right now, we're still off a little bit here. Let's see if I can get back on that. And, I mean, it's really touchy. You just got to take your time on it. Look at this. Barely touched that. Really, really touchy. Sometimes you can run it way one way or the other and trying to come back and hit it a little bit better. Okay. And sometimes not. There we go, right there. Okay. And then you'll do the same thing for the 200K, the 20K, 2 meg, so on and so forth. So, let me take that off of there. So let's check a couple of resistors real quick here. I think this one here, this is a 10K resistor, so we'll go to the 20K scale. This is a 10K 0.1, yeah. So I keep these, keep them in the bags and everything, so I know what they are. I use these for testing. 10K 0.1%. So let's see how accurate this meter is. 10.6K. So even with this, so you could take this and put this on there and get it to, let's see, let me take an alligator clip here. Clip that on there so that'll stay. Okay. And if you've got something like that or whatever, another meter, again, you find the 20K, here it is, here at the top. And adjust it. Well, I wish they'd use multi-turn potentiometers, but of course this was a cheaper meter and one of their low ends. Right there, that's close. So there's a 10K resistor, and we're getting 10K or pretty close to it. Okay, let me check another one here. I didn't mean for this video to get this long, but I just thought it might help somebody out if they're kind of reading through this book, and because it's kind of a little bit confusing on what they're showing. Let's see, here's 100 ohm, 0.1%. I know some of these are 0.01%, some's 0.1%. This is a 100 ohm, and we're in the 20K, so this is probably going to show zeros. Yeah. Down one. It's going to go down that 200. This is 100 ohm, it's showing 99 ohms. So you could still go in there and bump that maybe, but remember that one was off just a hair anyway. It's just very touchy. That's not too bad. It's normal for this to read, like if you're in the ohms position and you don't have anything hooked up, it's going to, you know, be over with some this 85, 86 here flickering, whatever. You know, a lot of modern meters just blank that out and have an over or say OL on them. I was just seeing, just touching them together. That's pretty good, 0, 0. So let me put that one back in there. And what else can we look at here? Let's do 100K real quick here and see how close that one is. Not went in there and adjusted the 100K or the 200K scale. So this should still show an over. Okay, 102K according to this, but then again you'd want to go in and the 200K, which is this one. Oop, see how touchy it is right there. Some of them don't seem to be as bad as the others. So there's 100K. So not too bad, you know, for this thing. But anyway, so there's that, going through the alignment procedure. Kind of clunky a little bit, but you're trying to do this on camera and whatever. But I thought you might find that interesting and follow up to the video and go through the alignment procedure, and maybe to help you out, kind of show you what they're talking about there. If you got the manual on it, this thing, you know, pretty much gives you a lot of details on everything. Besides, you know, fold out schematics and all that, it's even got, it shows you the waveforms here, all the test points and different places to check, all your what your voltage should be at different pins of different ICs and different diodes and different capacitors, and you put a scope on it, what it should look like. I mean, they really, I mean, for something like this, they really went all out. I've seen some that's not this detailed, you know, for a cheap one. Now the more expensive ones, you know, they usually are, but so they really did a good job in this thing. So this thing ain't too bad. You know, you think, well, this is a little cheap portable meter or portable, but you know, it does pretty good. And it's, let's see, this thing come out in 72, I believe. So not too bad. It'll be 50 or almost 50 years old. But anyway, until the next video, this is Michael, KE4EST 73.